Okay, let's begin to talk about piecewise functions. So these things consist of three things. The first one is the name of the function. The second thing is the list of all sub-functions. And then the third one is the domain, or the inputs that tell you when to use which function. So for example, let's say that I want to evaluate the value of 1. So I'm going to plug it into the function here, and then once I plug it in here, I have to make a choice. Do I evaluate using the first rule, or do I evaluate using the second rule? And the way in which you decide that revolves around knowing where your value exists. Does 1 exist in this interval, or does 1 exist in the second interval? Alright, so that's the name of the game. So let's practice with some concrete examples. So let's take a look at this one here. So it says evaluate at x equal to 2. Okay, so I'm going to plug into right there. So we need to evaluate f of 2. Alright, so now I have to make a choice. Do I use the first rule, or do I use the second rule? So now I have this interval here. So I'm going to kind of do it in a long way for now. So I have a 0, and this is a closed circle because of the bracket, and then I have a 4 with the open circle because of the parentheses. And then on the one on the bottom, I have a 4 closed circle, 8 closed circle. So now if I use common sense here, I know that my 2 is going to be somewhere in between this interval. Somewhere. Alright, 2 is not going to exist in between 4 and 8. It's going to exist within 0 and 4. So I'm going to use this rule right there. So everywhere I see an x, I'm going to replace it by a 2. So now I have 2 multiplied by 2, and we're going to subtract a 2 here. So I get that f of 2 is equal to 4 minus 2, and we get a value of 2. Okay. Alright, let's evaluate another point using that same function. So now we want to evaluate at x equals 4. So let's plug that in here. So we have f of 4. And now we have to make a choice. Do we use the first rule, or do we use the second rule? So we need to identify where 4 exists. Does it exist in this interval, or does it exist in this interval? And it looks like we have somewhat of a problem, because this one has a 4 and this one has a 4. So it's not really clear which one we have to use. However, since we are very good with the interval notation, we can clearly see that the parentheses here is telling the reader that 4 is not part of the solution. So whenever you have a value that gets repeated when looking at the intervals, you always want to look for the one that has the bracket. So here, 4 is a solution. So 4 exists. How do you spell exists? Exists here. So we're gonna use this rule, 3x. So everywhere we see an x, we're now gonna replace it by a 4. So I get 3 multiplied by 4, and 3 times 4 is 12. So f of 4 equals 12. Now we can extend piecewise functions to 3 sub-functions. We can actually extend them to however many we want. So here, let's try this one out. So we want to evaluate at x equal to 1. So we're going to plug in 1 here. So f of 1 equals, and now let's look at the intervals and see where 1 exists. So by scanning them for about a couple of seconds, we can see that 1 exists in this interval within -10 and +5. So we are going to use this rule. Everywhere we see an x, we're going to replace it by a 1. So we get 6 multiplied by 1 plus 2. And with some simple calculations, we can see that 6 times 1 is 6. We have to add that 2. So f of 1 equals +8. Let's evaluate a couple of more. So here we have at x equals 5. So let's plug that in. We get f of 5 is equal to, so let's skim through these intervals. And again, remember, we always want to look for the one with a bracket if the value is repeated. So this tells us to use this middle function right there, because again, we have a bracket on the 5 here. So everywhere we see an x, we're going to replace it by a 5 now. So we get 5 raised to the second power minus 3. And now 5 to the second power is the same thing as 5 times 5. Subtract 3. 5 times 5 is 25. And then once we subtract 3, we're going to get a total of 22. So f of 5 is 22. Okay, let's do a last one. So now at x equal to 15, let's plug in 15. So we have to evaluate f of 15. And you can see that if we scan the intervals, 15 is going to exist within this interval from 10 to +infinity. 15 is going to be somewhere in the middle here. Not exactly at the middle, but somewhere in between. And here we notice that we have a constant that's just there. There's no x. So typically I would say wherever you see an x, we replace it by 15 now. But since there is no x, the only thing we can copy is 7. There's no calculation to do, so we are done here. F of 15 is equal to 7. Alright, try the practice problems out. And any questions, again, feel free to message me.